Hello, grade 8. Welcome to your chapter 3 review on Pythagorean theorem. This section deals with a whole bunch of different topics, not just Pythagoras, but square roots and prime factorization. So as we go through these questions, if you haven't done them before, just press pause and try and answer the question yourself and see if you were right. If you have answered the question, you can just watch the video and see if you were right. And if you think you're right on a lot of the questions, but you just don't know a couple, just fast forward to the questions you need help with and follow along as we do the answers. Okay, question 1 is a true-false question. It says the number 36 has 4 prime factors. Well, in order for me to solve this question, I have to actually use prime factorization to find the answer to the question. So 36 is a number that has different ways to multiply. The first way we can multiply is 2 times 18. So what we say is 2 is a prime factor of 36. That means it's a prime number, and it's one of the factors that you multiply to get 36. 18, however, is not a prime number. It's what we call a composite number. So we can actually think of that as being 2 times 9. 2 is a prime number. 9 is a composite. So we can break down 9 into 2 prime factors of 3 and 3. And the numbers I circled are all of the prime factors that you would multiply to get the number 36. So 2 times 2 times 3 times 3 is 36. So 36 has 4 prime factors. The answer is true. Now, just as a side note, the reason why we learned about prime factorization, and you can watch one of my other videos on prime factorization, is to determine whether or not a number is a perfect square. So if we think about 2 times 2 times 3 times 3 as a way to get 36, if I was to rearrange those factors into 2 equal groups, in this case, a 2 over here and a 2 over here, and a 3 over here and a 3 over here, instead of saying 2 times 2 times 3 times 3, we could say 2 times 3 times 2 times 3, which is 6 times 6, which tells us that there are a pair of identical factors you can multiply, composite numbers, 6 and 6, to get 36, which means the square root of 36 means what number multiplied by itself is 36? The answer would be 6. So that's just one way to determine A, what the square root of a number is, and B, whether or not the number is indeed a perfect square. If we look at question 2, it says if a square has a perimeter of 40, then its area is 1,600 meters squared. So if I draw this square and put perimeter equals 40 meters, since we know all sides of a square are equal, that means that each of these had to be 10 meters in length. In order for the perimeter of a square to be 40 meters, each of the legs must, or each of the sides, would have been 10 meters. And if that was true, then the area would have been 100 meters squared, because we know the formula for the area of a square is side squared. Since the side is 10, we would have an area of 100 square meters. So the answer is false. Question 3 is 120 is a perfect square. Again, this is one of those, like question 1, it's a prime factorization question. So if you take 120 and break it down into its prime factors, you could go 2, which is a prime factor, times 60, which is not prime. Break it down into 2 times 30. Break it into 6 times 5, that's prime, and 2 times 3. Once I have all my prime factors, I have 3 2s, a 3, and a 5. If I was to rearrange those, there is no way I could rearrange those into 2 equal groups. The best I could hope for is a 2 and a 2 over here, and a 2 over there. That's the 3 2s. And maybe a 3 over here and a 5 over here. So 12 multiplied by 10 is one way, but these are not identical factors, which means that 120 does not have a pair of identical factors, which means that 120 is not a perfect square. So it's false again. Question 4. A triangle with sides of 18, 24, and 30 must be a right triangle, true or false? So the first thing I'm going to do is draw it. And since there are 3 side lengths given, I know that in a right triangle, the longest side is always the hypotenuse. So I'm going to put it there. And it really doesn't matter where we put the other 2 for legs. I'm just going to put these 2 here. And if this was a right triangle, then as Pythagoras stated, the area of the squares attached to the 2 legs of a right triangle will equal the area of the square attached to the hypotenuse. So 30 squared I know is 900. So the area of this square would be 900 centimeters squared. 18 squared, I think, is 326, 324. I better get my calculator. Sometimes I don't know things. 18 times 18 is 324. See, I knew what it was. I'll just keep that up there. This is 324. And the other one is 24 squared. Here's my x squared button, is 576. So if I take those and add the area of the two squares, so 576 plus 324, 0, carrier 1 is 10, is 900. So the area of these two squares add up to be the area of this square, which means that it does follow Pythagoras, which means that this has to be a 90-degree angle, which means it is a right triangle, which means your answer is true. Question 5 says a triangle has 3 squares attached to its sides. 2 of the squares have areas of 16 and 9 square meters. The third side must have a side length of 5. Well, the answer for this is false, because if I think about this question, and I take this picture here and I clone it, 16 and 9, if 2 of them are 69, this could be 16 meters squared, and this could be 9 meters squared, which would make this 7 meters squared, right? 7 plus 9 would be 16. That is one possibility. The other one was, if this was 16, and this was 9, and this would be 25, and since it says this must have a side length of 5, well, this would be, if this is 25 square meters, the side length, or the hypotenuse, would be 5. This would be 4, and this would be 3. So it's true for this one, but over here, since this is a possibility, right, the side length of the one we didn't know, the area of the square was 7 meters squared, and if I take the square root of that, the square root of 7 is actually 2.6. So in this case, this would be 3, this would be 4, and this would be 2.6. So there's an example of one that wouldn't have that side length of 5, which means it is false. Although this one was true, this was another possibility, and the answer was false. Tricky question. Question 6 says, what is a whole number whose square root is between 10 and 11? So if I was to draw a number line and put 10 and 11, this would be the square root of 100. And this would be the square root of 121 to give me a square root of 10 and a square root of an 11. And any whole number whose square root is between there would be any square root of any number between 100 and 121. Now the only one that's a number that's between 100 and 121 is b. Square root of 105 would be like 10 point maybe 2-ish. So therefore the square root of 105 is the answer. Question 7 says, what is a good number for x? Since this number here, the square root of 25 is 5, and the square root of 36 is 6, 5.5 would be here, 5.6 would be here. The only number that makes sense is a, 5.2. The square root of 27 is around 5.2. Question 8 is the easiest question in the test. It's Pythagoras' most simple statement. The area of two squares attached to the legs. This is a leg, and this is a leg. So these two areas here and here must equal 26. So this one has to have an area of 14 meters squared, which is your answer. Easy, easy question. Question 9 says, what is the approximate value of x? Well, this is a slightly more difficult variation of the last question. Since this area is 12 square meters, this one must be 14 square meters. And if the area of the square attached to that leg is 14 square meters, then the length of the side length will be the square root of 14. So the square root of 14 is 3.7. So therefore, x is approximately 3.7 meters in length. Question 10, what is the value of x? For this one, we are given the two legs. The first thing we need to take from this is that the area of this square would be 144 meters squared, because the area of the square is attached to the legs equals the area of the square attached to the hypotenuse. And if the area of that is 144, x would have to be exactly equal to 12 meters. Question 11 says, using prime factorization, prove that 144 is a perfect square. So 144, well, although I chose an easy one, I'm going to put 12 and 12, and right off the bat, that proves that it's a perfect square. But I'm going to pretend that we didn't know that, and I'm going to put 2 times 6, and 2 times 3, 2 times 6, and 2 times 3. And when I have those circled prime factors, I can break those into two equal groups. Over here would be 2 2's and a 3. And over here would be 2 2's and a 3. 2 times 2 is 4, times 3 is 12. Same thing over here. So because I could divide the prime factors into two equal groups, it is a perfect square. And not only that, the square root of 14 is 12, or 144, excuse me, is 12. Question 12 says, approximately, what is the square root of 120? Use a number line to show your thinking. Well, here we have to know that the square root of 100 is 10. And the difficult one, the square root of 121, is 11. The square root of 120 is actually a number that would go right around here on the number line, which means it's just a little bit less than 11, which means 10.9-ish is a really good estimation for the approximate square root of 120. Question 13, if a square, I'll draw it, has an area of 64 meters squared, the first thing you should do is just draw it. What is its perimeter? Well, if the area is that, then I know the square root would be 8 meters, and since it's a square, all sides are of equal length, so that's 8 meters here as well, 8 meters here as well, and 8 meters here as well. 8 times 4 is 32 meters. So the perimeter of a square with 64 square meters of area would be, the perimeter would be 32 meters. Question 14 says a rectangle has side lengths of 10 and 6. So here's my rectangle, 10 meters and 6 meters. What is the length of the diagonal? So I'm going to draw a little dotted line here. Really what this question is asking you is, do you see the diagonal of a rectangle as being the hypotenuse, and I'll just erase this part here, the hypotenuse of a right triangle, of a right triangle. So really, if I cut away all the superfluous information, I get this. I can attach my legs onto, or my squares onto the legs, attach the square onto my hypotenuse. The area of this square would be 100, the area of this square would be 36, the area of this square would be 136, which would make the hypotenuse, or in this case, the length of the diagonal. The exact answer is 100, the square root of 136. That is an acceptable answer. But if you wanted to give an approximate answer numerically, the square root of 136 is approximately 11.7 meters. Question 15 says, what's the approximate perimeter of this triangle to the nearest tenth of a meter? This is kind of an interesting one because we know that the formula for area is base times height divided by 2. I know my base, it's 8, but I don't know my height yet. So there's got to be a way I can figure out my height. And there is, because if I take this triangle, right, and I put the square root of 39 as the side length, and I put 5 meters here, I'm going to put squares onto all of these and see if we can figure out what this is. So if the side length of that hypotenuse right here is the square root of 39, that means the area would have been 39 square meters, right? And if this one was 25 square meters, because the side length is that, then this one must have had, I think I messed up here. Oh, did I do that wrong? I think I made this question much more difficult than it needed to be. Oh, well. Oh, what's the perimeter? Oh, I don't need the height, that's why. Okay, forget everything I just said. I can't erase time, so I thought I said area. It says perimeter. So all I need to do is get this side here. Oh, no, I do need all that stuff. I'll come back here in time. What I don't need is this here. Okay, so given this one is 14 square meters, okay, which means this here is the square root of 14. Oh, this is going to be complicated. Oh, why did I do this? Oh, I'm so stupid. So 25 square root of 39, 39, 25. What did I think that was going to add up to? Oh, I see what I did. I thought it was going to be 64 and make that 8. Oh, boogers. Okay, 15 is too tough because the actual length of this is the square root of 14, which is approximately, oh, this is going to be awful. Let's just do it anyway. So the square root of 14 is roughly 3.7, which makes this length here I'll erase all this. This length here, 3.7. Okay, so now we need to take this new triangle, put 3.7 here and 3. Oh, this is the worst question I've ever asked. If I put squares on each of these and put 3.7 squared is, I'm going to put just 13.7 roughly. 13.7 goes here. 9 goes here, which makes this roughly 22.7, which makes this side length approximate the square root of 22.7. So 22.7 square root is roughly 4.8. Okay, so now this is 4.8. This is the square root of 39, which we think we said was 6.2. So the perimeter around the whole triangle would be 6.2 plus 4.8, which is 11, plus an additional 8. 11 plus 8 is 19. Oh my God, did I screw this up? I think I did, but I don't know what I did wrong. And I'm already recording. It's live, and I don't know if that's the answer I was looking for, but I think the perimeter equals 19. If I messed up, please leave a comment and tell me where I messed up. And if I didn't, that's the answer that I will accept. Somewhere around there is probably good. Okay. The other question I asked you about Mr. Bridges and Mr. Connell, we'll go over that answer tomorrow. If you have any questions, leave either comment in the comment box or just see me tomorrow when we do our corrections.